Hello class, this is Mr. Parsons here. I just want to take a few minutes to talk to you about transformations of quadratic functions. And so we want to look at, first start looking at translations, the sliding and movement of our parabola, which is our quadratic function. And so we have vertical translations, either you're moving up and down, and I'm going to explain that. And we got a horizontal translation, you're going to move either left or right. Let's talk about vertical translations. So vertical translations, you have like, think about your leading coefficient, the variable is x squared. All right, so x squared either plus k, the variable k just represents a vertical movement. If it's plus k, whatever that value for k is, it's going to move up that many units. If it's minus k, then it's going to move down that many units. In this example here, x squared minus 4, so the k here is -4, and since it's -4, it's going to represent a vertical movement of 4 units down. We're shifting our parabola and moving it 4 units down. All right, so this is the parent function f of x. F of x is just x squared, so if you just graph x squared, it's a parabola where it's going to cross your origin at 0. So your y-intercept is going to be 0. All right. And so here, this is the parent function. This is the g of x. Notice what's happening here. I move down 4 units. All right. So this just shows a vertical translation of 4 units down. Now let's look here. This is the parent function. This is the translated function of m of x. Let's see what happens. We move down 7 units, so we can write m of x equals, and you could put either x squared or f of x because f of x is x squared, so you could put x squared minus 7 or f of x minus 7. It's the same thing, and this is representing a vertical translation of moving 7 units down. All right, let's take a look at this. So we're doing a check here, and we have x squared minus 8, and we want to describe the translation. Well, if it's minus 8, that's letting us know that we're moving down 8 units. So this is a parent function of movement of 8 units down. Now let's look at horizontal translations. Now look at the difference here. All right. Now vertical translations is like x squared plus k, or x squared minus k. Here is the general statement is in parentheses that whole expression x plus h or x minus h. So k, the variable k, represents a vertical translation. The variable h represents a horizontal translation. So we're moving horizontal, we're moving either left or right. So similar to linear functions, similar to exponential functions, with horizontal movement, if we're adding, right, we're moving to the left. If we're subtracting, we're moving to the right. So if this is x plus 2 squared, I am shifting my parabola and moving it 2 units to the left. All right. And so look here. So this is my parent function. I am shifting it and I'm moving it 6 units to the left. And so my x, my x, and then since it's moving to the left, is going to be plus. So x plus 6, that whole expression is going to be in parentheses. So it's going to be g of x equals f of x plus 6. You can notate it that way, or you could say g of x equals x plus 6 squared. Both of these are really saying the same thing. All right, because remember, f of x equals x squared. And if we substitute x squared for just x plus 6, it'll be x plus 6 squared. So either way would work. All right. Now, if we look here, if we do a check here, x minus 6 squared. All right. So this represents a horizontal translation. So this is meaning I am moving 6 units to the right. 6 units to the right. All right. Let's take a look here. Now we have multiple translations. So here, this represents a horizontal translation, And then this represents a vertical translation. So this tells me I am moving 3 units to the right, and then I'm moving 1 unit up. So we're moving 3 units to the right, and we're moving 1 unit up. All right, let's take a look here. Let's describe this transformation that's going on. This is our parent function. This is f of x. So it looks like we're moving 3 units to the left. So if it's 3 units to the left, the whole expression is going to be x plus 3. They represent 3 units to the left. All right, and then we're moving 10 units down. So that's going to be either f of x plus 3 or x plus 3 squared, and then minus 10. And that's going to represent our multiple transformation here. F of x plus 3, or it could say x plus 3 squared minus 10. And that represents our multiple transformations here in this particular graph. So if we look at this check, all right, we're trying to see what's going on here. All right, our parent function, x squared. All right, and this is x plus 3 squared. This represents the horizontal transformation. So this means I am moving 3 units to the left, and then I am moving 5 units down. 3 units to the left, 5 units down. All right. Now let's talk about dilations. Dilations is not necessarily a movement or a sliding of the parabola. It's either a stretching or a compression of your graph. So you're actually doing something with your parabola itself. So if we look at a vertical dilation, we're multiplying. Think about the leading coefficient here. All right. So if your leading coefficient here is greater than 1, you're going to have a vertical stretch. It's going to be more narrow, your parabola. If it's less than 1, greater than 0, it's going to be a vertical compression, but the parabola is going to be more wider. All right. And so let's take a look here. So we got g of x equals 3. So 3 times the parent function is greater than 1. It's going to be a vertical stretch, and it's going to make the parabola more narrow. Right. So this is the parent function. Look at, it's more narrow than the parent function, and it represents a vertical stretch. So you're multiplying it by a scale factor of 3. And let's take a look here. This is the parent function f of x. This is our transform function of r of x. Now, out of these answer choices here, we want to determine what could be the number that we multiply by to get this function here. So it looks like that this transform function is more wider than our parent function. So that's going to let me know that it's going to be less than 1 and greater than 0. And this also tells me, since it's wider, it's going to be a vertical compression. So if I look at my answer choices, well, this is going to be more narrow because it's greater than 1. This is also greater than 1 because it's going to be more narrow. Well, 4/3 is greater than 1. 1/3 can work. D, even though it's a negative here, that's going to represent a reflection, which we're going to talk about in a minute. So actually, we're looking at C. C would be more likely to be that value that we'll use to multiply by our parent function to get r of x, because it's less than 1 and greater than 0. All right, let's talk about horizontal dilations. Now look at the notation here. Now you have in parentheses, all right, a number times x and then squared. The squared is on the outside of your parentheses. That represents a horizontal dilation. It's still going to affect your parabola, just a little different. So if it's greater than 1, it's still more narrow, the parabola, but the horizontally is a compression. Instead of a vertically, it would be a stretch, but horizontally it's compression. All right. Here, if it's less than 1, greater than 0, it's still wider, but horizontally it's a stretch instead of a compression here. All right. So let's take a look. And in parentheses, we got 1/2 x in parentheses, and then to the second power, 1/2, that is less than 1, but greater than 0. So it's going to be wider, but it's going to be a horizontal stretch. Okay, so this is the parent function. It's still wider, but horizontally, it's a stretch. All right, let's take a look at this. It says, let's see which one of these best describes the horizontal dilation. So this is the parent function. This is the translated function. This is dilated. All right, notice it's more narrow. Okay, so it's going to be greater than 1 because it's more narrow, but it's going to represent a horizontal compression. And so all of these answer choices is given. The one that will probably best fit will be answer choice B. All right, f of 2x. All right. Now let's talk about reflections. So reflections, and we kind of mentioned this in the previous lesson. So think about when we, especially with your leading coefficient. If your leading coefficient is negative, you're going to have a downward parabola. If your leading coefficient is positive, you're going to have an upward parabola. So that's kind of leading us into reflection. When you multiply by a negative number, that parabola is going to reflect either across the x-axis or across the y-axis. Now with a vertical reflection, you're going to reflect across the x-axis, and it's going to be apparent because it's going to be a downward parabola. Now with the horizontal reflection, you're reflecting across the y-axis. Your parabola is still an upward parabola, but it may be different somehow when you're looking at certain points on your graph. All right, so when I'm looking at this vertical reflection here, negative, so this is our leading coefficient, negative 2/3 x squared. So since it's negative, we know that we're going to have a downward parabola. It's going to reflect across your x-axis. So this is the parent function, and it's going to be reflected across the x-axis. And since 2/3, think about 2/3, 2/3 is less than 1, and so that means it's going to be wider than your parent function. All right, and so it's going to represent a vertical compression. So it's going to reflect wider parabola, vertical compression. All right. Now let's look at this. So this is a different notation. Look, it's in parentheses, all right, with a negative. So negative 3 of x squared. So this one is going to be reflected across the y-axis. You're still going to have an upward parabola, all right. And this is, since it's greater than 1, it's still going to, your parabola is going to be more narrow, all right, but horizontally it's going to be a compression. All right, so this is the function. This is our parent function. So let's say like this is the original point, and then we multiply by -3. All right, then we're actually going to flip this to this side, but then it's going to come in more narrow. All right, so it's still a upward parabola, but it's just going to flip across the y-axis. It's going to be more narrow, and then horizontally it's going to be compressed. All right, so that is basically your transformations there. All right, you know you got your vertical and horizontal translations. Either you're going to move up or down, so you're going to add to the function or subtract to your function to move up and down. Horizontally, it's going to be in parentheses, and if we're adding to our function, we're moving to the left. We're subtracting to our function, we're moving to the right. If we're doing a dilation here, we're going to multiply by our function. If it's greater than, if it's vertical, all right, greater than 1, it's going to be narrow, vertical stretch. If it's less than 1, it's going to be more wider. It's going to be a vertical compression. And horizontally, it's going to be in parentheses. Greater than 1, still narrow, but vertical, horizontal compression. And then less than 1, still wider, but horizontal stretch. And if we multiply by a negative number vertically, it's going to be a downward parabola. All right. If we do by a negative number horizontally, it's going to flip across the y-axis, but it's either going to be more narrow or more wider, depending if it's less than or greater than 1. So I hope this helps with our transformations.